Hello everyone. Today we are going to be talking about solving exponential and logarithmic equations. Now this is in the book section 7.5 and 7.6 because really the only difference between the two is 7.6 talks about a base that your book's kind of been avoiding so far, and that's just this natural log, which really isn't that big of a deal. All natural log is that it's a base of e and not 10 or any other number. So the reason it's ln it comes from Latin, but we don't need to worry about that. So there are really 4 different cases. And even sometimes within these cases they might look different, but still your overall strategy is going to be the same. So case 1, I've sort of been sneaking in all along. So these are going to be the exponentials, and these problems can be written as a common base. So for this particular problem, we have 27 to the 3x equals 81. Well, 27 and 81 are both powers of 3, so I can rewrite this as 3 to the 3 to the 3 to the 3x, so 3 to the 9x equals 3 to the 4th. We set those exponents equal to each other, so 9x equals 4, and x equals 4/9. Like I said, I've sort of been sneaking these in all along. Not a big deal. Now, what about the ones that can't be written as a common base? Now, sometimes we might rewrite them as a log, but occasionally they might have something else thrown in with our exponent that might make that log kind of awkward. So, what we can do is we can use the idea of the log as an operator. So I can do a log on one side and a log on my other. Sort of like how I would add something to both sides or square both sides, very similar. So remember, with our properties of logs, we have an exponent. It's going to come out in front. So I have that 2x exponent that came out in front, log of 5 equals log of 130. And then all I want to do is get that x by itself. So I'm going to divide by both sides with that 2 log of 5. They're sort of in the way. We can pull that up on our calculator. So we have that log of 130, close the parentheses, divided by, and I want to divide by this whole thing, so do also make sure that this denominator is in parentheses, because otherwise it's going to follow the order of operations. Just divide by this, and then multiply by this guy. So 2 log of 5. And we get about 1.512. So those are really your cases for exponentials. The only other thing that they might do for you is give you a base of, like, exponential base of e, which you're always going to necessarily have to, use that log operator, or in this case, we can actually use natural log, which is actually going to make this a lot nicer for us. So if we get that exponent part to itself and divide by 4, I have e to the 2x equals 3.5. And then, so up here, I just took the log of both sides. I can do the same thing here. I can just take the log of both sides, or if I take the natural log of both sides, I have 2x natural log e equals natural log of 3.5. Now this natural log of e, we understand that it's a base of e, so it's kind of like, hey, well, power of e is e, and that's just 1, so that cancels out nicely for us. So I've got 2x equals natural log of 3.5, divided both sides by 2. So I've got my natural log of 3.5. And on the inspires, it is going to be the second, like, e to the x button, divided by 2. And we get 0.626. So if you have an exponential with a base of e, you can use the natural log. Like I said, you can use log on both sides. You will end up with the same answer, interestingly enough. Just the log of e is not going to cancel out for you. Now, on the flip side, if we have logarithmic equations, there are two cases here. So you either might have a single log on one side. You may have to isolate it, but in general, if you have one log, you're always going to rewrite. So take it from the base to the exponent equals your argument. So in this case, my base is 10, so 10 squared equals 4x minus 3. So I've got 100 equals 4x minus 3. And then you just have a two-step equation. Add the 3, divide by 4, and x equals 25.75. If I have a single log, I might also have like a squared. In this case, remember my base is e. So when I rewrite this guy, I've got e to the 4th equals 3x plus 5 squared. Please do not FOIL this out. Solve by square roots. You have something equals something squared. So square root both sides. Remember, when I introduce a square root, I do have to put that positive or negative. It'd be positive negative e squared for purposes of just ease. I mean, that's approximately 7.389. We typically don't want to round to the end, but we're only going to be subtracting 5 and dividing by 3, so it's really not going to matter. So that equals 3x plus 5. Subtract your 5. So I've got negative 5 plus or minus 7.389 equals 3x. And that's all going to divide by 3. When I punch that into my calculator, I get x values of about 0.796 and negative 4.13. So we would type this in, divide by 3, type it in with the subtraction, divide by 3, and you get those two numbers. So you may get one answer, you may get two. Sometimes, and I'll show you in a second, you may have to check that your answer looks valid. Last case, and again, even with these, there might be slight variations, but if I have multiple logs and a constant, so I have that constant of 1, use your properties to combine these two logs. So here I'm adding, so I would be multiplying my arguments. So I would have log of x squared minus 3x, since I multiply this argument with that one, and I would distribute my x. So that is equal to 1. So all I've done is combined my logs. Now I'm kind of down to the previous case, which the very first one we did wasn't too bad when I rewrote. This one when I rewrite, because I have that squared, I am going to have to factor. But they're all going to be factorable, it's not going to be terrible. So we've got 10 to the first, which is just 10, equals x squared minus 3x. Move everything to the side of the positive x squared. So I've got x minus 5, x plus 2. Since negative 5 and positive 2 multiply negative 10, but add to negative 3. This tells me that x is 5 or negative 2. Check your answers. Really, all you have to check, you could actually plug them both into your calculator because they're both common log, but I know I can't have a negative argument because there is no power of 10 that would get me that negative 2. So that one's out, and x just equals 5. So if you have multiple logs, just make sure that you combine them using your properties, and then you're kind of back to case 3 where you have a single log and a constant, and you're just rewriting and solving. So we'll practice more of this in class, but for now, thanks for watching.